Hello everyone, welcome to the first part of our tutorial series on the game Geometry Dash. If you haven't checked out the other tutorial series on the game Dodge of Creeps, make sure to do that first because this game is much more complicated and it builds off the knowledge you would have learned in the first tutorial series. And just as a reminder, these tutorial series go along with the in-person meetings we do at school, so if you miss one of these meetings, you can just watch the tutorial series online. So first, as usual, go to tinyurl.com/gdassetfiles. So go to this link. We'll have it included in the description also. This link goes to a Dropbox, which has all the files necessary for this game. So once you come to this link, click the download button here. And it'll take a while to download. If you're on the web, as usual, use the Godot Engine web editor. Otherwise, download the Godot Engine from online. So once it's done downloading, click choose file to preload project zip, go to downloads in your Geometry Dash starter, open up and click start Godot editor. Now this might take a long time if you're on the Chromebook, but first give it a project name it Geometry Dash. Make sure you click create folder before you click install and edit. And after that, just wait a bit. And as I said, if you're on a Chromebook, this might take a while. Once you're loaded in, make sure you can see there's assets in audio, which we provided. So now what we want to do first is we want to make a player scene. So click other node. It's going to be a rigid body 2D. So there are three types of physics bodies in Godot: rigid body, static body, and kinematic body. Rigid body is anything that's just affected by the physics engine, like a ball that's bouncing up and down. Static body is just something that doesn't move. It's static. And kinematic body is controlled by the script, and it's not influenced by physics. But we need a rigid body this time since we want it to be influenced by physics. So first, we want to add the collision shape. We'll make this a new rectangle shape. Make it 30 by 30. You can see here. We also want to save the scene after we name it player. So name it player and save the scene. I also want to add an area 2D. And for an area 2D, you have to also have a collision shape 2D. Make the collision shape 2D the same size. And now in this area 2D, after you made the collision shape, go to collision. Here we can see we have layer 1 and mask 1 selected. Disable both of them and only enable layer 2. I'll explain more about why we do this later on. And now going back to the player, here we can see all the physics characteristics. Make the gravity scale 38 since the gravity will be fairly high for this game. And down in linear, make velocity damp to 0. And also go down to angular damp and also make this 0. Now what we want to do is go to debug and click visible collision shapes. This means that when we run the project, we'll actually be able to see these collision shapes. So make sure you go to debug and do visible collision shapes. This is just for testing for now. So if you play the scene, you will see the drops down and we can actually see that blue blob for a bit. So now add a sprite. And this sprite will be the player. In the texture, go to assets and we provide one character.png, drag it in. As you can see, it's a bit big. So what we want to do is go into offset. No, not offset. And transform and scale. So this image, if you double click this character.png, you can see it's 310 by 310 pixels, but we want it to be 60 by 60. So what we can do is in this scale, you actually type in a fraction, so we can do 60 divided by 310. It has to be 0.0 since it has to be divided by a float, otherwise it won't return a float. If you do that, click enter, it'll give you a float. So it's again 60 divided by 310.0. Now it should be aligned with the size of the collision shapes. Now saving the scene, let's add a script using this button. Great. Now what we want to do is the ready function. First we want to make the linear velocity. The geometry dash are always going forward, so we want to set the x velocity to 500. And since we want to slow down, make friction equal to 0. And now we want to make a new function called physics process. So anything made by Godot has an underscore, so type underscore physics process, and you'll see it. So what physics process does is that runs every physics tick. So we've looked at process. Process runs every frame. Physics process runs every tick for the physics simulation. So this makes sure that all the physics stuff is up to date. And here we also want to set the linear velocity x component equal to 500, since we want to make sure we're moving forward. We also want to do if input dot is action pressed, not just pressed UI up, which is already made for you. And UI up is just the up arrow key. And if so, we want to set linear velocity dot y equal to -1000. This means that if the up arrow key is pressed, then the linear velocity dot y goes up. Negative and negative corresponding to Godot world is upwards. Upwards is negative, downwards is positive. So now to test this out really quick, make a new scene, 2D scene, and name it game, and save the scene. Now going back here, let's add the player by instancing it. So click up here, instance child scene, player.cscn. Now we can drag this player to the middle to see. But obviously it'll just fall through the floor. So what we want to do is add a static body 2D, add a collision, shape 2D. We'll make this a floor for now. So this will be a new rectangle shape. We just make the x extent really big because it's the floor. This is just for testing for now, the y, stuff like that. And drag it on the floor. There, make the player right above it so we can see. So now if we run this main scene, which we want to make the main scene, we see that player moves and we can jump. If you play it again, notice how we can jump while in the middle of the air also. So this is because if we go back to the script, we can see that it's only checking if the up arrow key is pressed. It's not checking whether we're on the floor or not. Godot doesn't do this for us either, so we need to do this manually. So what we want to do is back here in the game, in the stack by 2D, go to collision, and then enable mask 2. So what this does is mask. There's different layers to the physics in Godot for 2D. So if we have a mask, that means it's in this layer. It's saying I'm in this layer. So the floor is in layer 2 also. And now if we go back to player, remember in Area 2D, we only had layer 2 on, which means it only detects anything layer 2. So the reason we have to do only layer 2 is because the player itself is in layer 1. And it would hit itself. So it has to be only layer 2, which is why we made only layer 2. So make sure the Area 2D is only layer 2. And the floor has mask 2 enabled. So now going to the script, connect the Area 2Ds, go to node, body entered, and body exited to the player script. Now make a new variable called isOnFloor. And it should start off as false. Now what we want to do is, if a body's entered, which means we hit the floor, what we want to do is on floor equals true. And if it exited, then is on floor equals to false. So now if we test this really quick, nothing would happen since we're not actually using is on floor. So we need to do is on floor and is action press. So now it's checking if we're on the floor and the up arrow key is pressed, then we move. So now going back to game, playing the scene. We see that when we can only jump when we're on the floor. If you hold the arrow key down, you'll continue jumping in the air. So this is exactly what we want. So now what we want to do is actually make the camera follow the player, otherwise the player just goes off the screen. You can see the screen size is depicted by this blue line here, so that's the screen size. So if the player exits it, we won't be able to see it anymore. However, we can actually add a camera. So add a node, camera 2D. Nope, wrong node. Creating camera 2D node. Going back to inspector. We want to set the anchor mode to fixed top left. So it's fixed top left, and now it should align up with our blue line, which is actual scene. Select current as on. So making current means we're actually looking through this one camera when the game plays. Now I'm going back to the script. The game, which we haven't made yet. So going to game, make a new script first. In here, one on process, in process. So every frame, we get the position of this camera, the X position, and we set it equal to the position of the player. Minus position.x first, minus like 200, so that the camera is a bit behind the player, so we can see the whole player. So now if we test this code really quick, now the player just stays in place, but it's still moving. It's just the camera's following along. Now if we jump, we should be able to see that it's jumping correctly. And this blue box is the physics. Stack body, which we can see since we have debug collision shapes on. So if we're seeing we're going into the floor a bit every time we jump, this is because our gravity is very high. Then when it does the interpolation for physics, it can't handle it because it's running the tick speed too slow. So what we want to do, going back to the editor, go to project, settings. Here there's a bunch of settings you can play around with if you want. Go to physics and common, and change the physics FPS to 120. So now it'll run the physics simulation 120 times a second. If your computer can run anything faster, then you can up it even more. But you should probably wait till the end, once everything's done, to see. So now it's much better. We don't go on the floor. At least much less, because the physics is now faster. The physics tick speed, not the actual simulation. Now that when we play a scene and the camera follows the player, what we now want to do is add rotation to the player, just like geometry dash. Whenever you jump, the player rotates a bit. So going back to the player rigid body 2D, make sure you have the linear damp set to 0 and the angular damp set to 0. This way it doesn't slow down the angular velocity while it's moving. And when we jump, so this is where we jump. We also want to add angular velocity equal to 6.3, which I found 6.3 makes it jump a whole 180 degrees every single jump, which is what we want. So if we play the scene, see if it works. So if you play the scene and you're getting these weird physics issues, most likely either the physics tick rate is high enough, but we were set to that's high enough, so it has to be some other issue. So if you're having these types of issues, make sure you go back to game and look at the static body 2D made for floor and collision. If the extent is too big, it actually won't work since it messes up the physics engine, since there's not enough floating precision. So make sure it's big but not that big. So like that would work. So if we rerun the game, See that? It works perfectly now. So this is exactly what we want. So now that it's all done, let's make a simple testing. So going back to the game scene, let's add a new static body. And this is just for testing for now. We're making a simple prototype to see if the game would actually work. Static collision, shape 2D, and new rectangle shape. And we can just drag this one, these manually. Like that would work. And we can duplicate this a few times. Just Control D. So now, just before we do that, let's create this new shape again. Let's make it such that you can't select that child and only leave the whole thing together by clicking that button. Now let's duplicate this a few times. Now we can move this to make a simple level. Now if we run it, you should see that. However, we can't seem to jump while we're on it for some reason. And that is because if we go back to the stack body, we can see that these collision, we need to enable mask 2. Because as we remember, mask 2 was this area 2D's layer, which detects whether we're on the floor or not. So we have to enable mask 2. So if we enable mask 2 here, you should see that it doesn't enable mask 2 there either though. Because these root nodes, they're not, when you duplicate them, it makes a copy, it doesn't make a reference. So make sure you enable mask 2 for all of your collision shapes. However, if you actually edit the collision shape itself, it changes all of them because they reference the same point. So now testing the scene really quick. If it says that, you can just reload the page. See that we now jump. So let me reload the page. So if it says WebGL out of context or anything, just reload the page and go back to the game. Now if we play the game, you'll be able to see that we can jump on these platforms like that. Then if you play the end and test, and on the four works, it says whenever we touch an object. However, if we touch the bottom of these, it also lets us jump. If you saw it right there, we were sticking to that. Obviously, if you just don't move, see, we're able to jump from the bottom. And that's because if we touch the bottom of this collision shape, it thinks we're on the ground. We'll fix this next week after we add collision detection for and you die. Like if you hit a spike, we'll add like stuff on the bottom. So if you hit that, you also die. So obviously just make it testing for now. We'll delete this later, but this is just for testing for now. So stay tuned for next week's tutorial where we'll add spikes in objects that you need to dodge. Thank you for watching.